This is a revision video for Year 8 topic 8H, Igneous and Metamorphic Rocks. By the end of this video, you'll be able to answer the following questions. What are igneous and metamorphic rocks? How does the rate of cooling affect igneous rocks? Can you identify igneous and metamorphic rocks from their features? This image shows the structure of the Earth. The outside of the Earth is called the crust, and just underneath the crust is the mantle. At the centre of the Earth is the core, which is made up of two parts, the outer core, which is a liquid, and the inner core, which is a solid. How do you think the Earth is like a hard-boiled egg? Igneous rocks. Can you think of any other words that start with IGN? How about ignite, to cause something to burn, or ignition, the electrical system in a car, for example, that provides a spark to ignite the fuel. What do they have in common? They all are to do with fire. Igneous rocks are fire-formed rocks. They form when molten rock cools down and freezes. So how do they form? The molten rock which reaches the Earth's surface is called lava, and we can see this coming out of the volcano. When the molten rock cools down, it solidifies to form igneous rocks. Rocks formed when lava cools above ground are called extrusive igneous rocks. You can think of it as being like exit for going out. Lava cools quickly in the air or underwater. Magma that is trapped underground cools very slowly. This is because the surrounding earth acts as an insulator. Igneous rocks that form underground are called intrusive igneous rocks. They are formed inside the earth. So how are intrusive and extrusive igneous rocks different? We can see some examples of these rocks down the side of the screen. When molten rock cools very quickly, it can form rocks that look very glassy, for example, obsidian, this first image. When molten rock cools down, it usually forms crystals. When it cools down quickly, it forms rocks with small crystals, for example, basalt. However, when molten rock cools slowly, the crystals have more time to form and the rock has large crystals. An example of this is granite. So why do the rocks have different crystal sizes? When a rock is a liquid, the particles are free to move about. As the liquid cools down, forces between the particles make the particles form a regular grid pattern called a lattice. If the rock cools slowly, there's plenty of time for the lattice to form and large crystals are made. If the rock cools quickly, there's much less time for the particles to become ordered, so the smaller crystals are formed. If the rock cools very quickly, there's even less time for the particles to get into an ordered arrangement, so the rock doesn't form crystals at all and it looks like glass. This diagram just summarises what we've learnt about. Another type of igneous rock is pumice, and you might have some of this in your bathroom. When volcanoes erupt explosively, gases can get trapped in the lava, and the rock that is formed has holes in it, which we can see trapped here. Let's have a quick quiz. Decide whether each rock is an intrusive igneous rock or extrusive igneous rock. You need to look at the size of the crystals to help you to decide. So pegmatite has large crystals, so is an intrusive igneous rock. Diabase has small crystals, so is an extrusive igneous rock. And diorite has large crystals, so is an intrusive igneous rock. Another type of rock is metamorphic rocks. What does the word morph mean? Morph means to gradually change. So metamorphic rocks are rocks that are formed when other rocks are changed by heat and or pressure. The rock gradually changes without melting as new minerals form. The rock is compressed or squashed, and the minerals line up in bands or sheets that are often coloured, and an example of this is gneiss. Here we can see the fine lines and bands in the rock. Here's a little experiment you can try. Try scattering your pencils on the desk. Then, using your arms or two big rulers, squash the pencils together. What do you notice about the pencils? They should all line up. And this is what happens when metamorphic rocks form. Here are some examples of metamorphic rocks. In the slate, we can see the fine lines and bands as the layered structure of the slate. And here we have two more examples of metamorphic rocks. Finally, for a little fun quiz, can you state which type of rock each sweet or cake is like? Is it igneous or metamorphic? Or can you remember from another lesson, is it sedimentary? Did you get them right? At the end of this video, hopefully you can now answer these questions. What are igneous and metamorphic rocks? How does the rate of cooling affect igneous rocks? Can you identify igneous and metamorphic rocks from their features? And lastly, how many rocks do you have in your home?